Hello everyone, I'm Houghton from ETH Zurich. Today I will present graph transform GANs for graph constrained house generation. So the goal of this paper is to address both house layout generation and house roof generation. To this end, we propose a lower graph-based, a transformer-based network GTGAN for the challenging graph constrained house generation task. To the best of our knowledge, GTGAN is the first transform-based framework enabling more effective abstraction reasoning for generating house layouts and validating adjacent constraints. Second, we propose a lower graph transformer generator that combines both graph convolutional networks and transforms to explicitly model global and local correlations across both connected and non-connected nodes simultaneously. Third, we also propose a new load classification-based discriminator to present high-level semantic and discriminative features for different types of rules. And lastly, we propose a lower graph-based cycle consistency loss to guide the learning process toward accurate relative spatial distance of graph loads. So this is the overview of the proposed GTGAN and house layout generation. It consists of a lower graph transform-based generator G and a lower load classification-based discriminator D. The generator takes graph loads as input and arms to capture local and global relations across connected and non-connected loads using the proposed graph modeling block and multi-head load attention, respectively. Note that we do not use position embedding since our goal is to predict the positional node information in the generated house layout. The discriminator D arms to distinguish real and generated house layouts, and simultaneously classify the generated house layouts to the corresponding rule types. The graph-based cycle consistency loss allows the relative spatial relationships between ground truth and predicted loads. The whole framework is trained in an end-to-end fashion so that all components benefit from each other. So this is an overview of the proposed graph transformer encoder, which consists of multi-head load attention and a graph modeling block. It can capture both global and local correlations for graph constrained house generation. This enable consists of 8 identical blocks. The proposed connected load attention arms to capture non-range relations across connected loads. Loads that the proposed non-connected loads attention has the same structure as connected load node attention, but takes non-connected loads as input. It arms to capture non-range relations across non-connected loads. So we compare GTGAN with the most related methods on house layout generation. So the visualization results and the 5 subsets are shown in these figures. It is easy to tell that GTGAN generates more realistic and reasonable house layouts than the leading methods, namely house GAN and house GAN++. So let's see more results. So the right table shows our main results on the 5 subsets. We observe that GTGAN outperforms other competing methods in all the metrics validating the effectiveness of GTGAN. We show 2 examples of the learned load attention in the figure. The query loads are colored in black, whereas the edges are colored according to the magnitude of the attention weights, which can be referred to by the corner bar and the left. So we can observe that the proposed method indeed learns the relationships between nodes. So we'll also compare GTGAN with the most related methods roof GAN and house roof generation task. Clearly, we observe that GTGAN generates more realistic and reasonable roof structural stands than leading methods roof GAN. For instance, roof GAN generates isolated too long, too high, or too thin roofs. It also produces poor relationships between different components, which results in unrealistic shapes and topology. In contrast, GTGAN elevates all these problems to a certain extent and generates more complex and realistic combinations of roof primitives. Moreover, it can also produce more diverse roofs, which is another advantage of our method. So, to evaluate the effectiveness of GTGAN on house roof generation, we compare it with the three leading methods: PQNet, house GAN, and roof GAN. This table shows that the comparison results on both 3 and 4 primitives. We observe that GTGAN outperforms the other 3 competing methods in both metrics, demonstrating the effectiveness of our method. Thanks for your attention, and please check our code online.